everyone, and for this opportunity to present my research. So today I want to share with you all my project titled An Intelligent Mobile Application to Identify Factors Influencing Adolescent Mental Health Variability Using Artificial Intelligence. Let's first start with an introduction for why the topic of youth mental health is increasingly important. So in the past decade, depression and anxiety in young children and adolescents have increasingly gained attention. According to some studies, 40% of children will meet the criteria for an identified mental health condition by the age of 18. Childhood depression is caused by genetic and social factors, and they have long-term consequences that can affect adulthood well-being and influence factors such as overall emotional well-being and suicidability in the future. Also, the diagnosis rates of childhood mental illness have increased dramatically in recent years. Due to the complex nature of mental health, we often see frequent underdiagnosis or misdiagnosis. This is a special problem for young people because they are often seeking more trustworthy resources that are often unavailable to them. The widespread nature of mental illness puts a severe strain on psychologists. According to a recent survey, about 40% of mental health professionals in the United States are burnt out and they don't have new openings, leading to really long wait times for newer patients, and they're often unable to get the access they need. This is even more a problem in underrepresented communities, such as those of low income, who may not have equal access to mental health professionals. A novel approach to the problem of youth mental illness involves using mobile apps and artificial intelligence as a cost-effective and widely available support tool. Previous research demonstrates the efficacy of artificial intelligence and natural language processing in identifying mental health conditions and providing user support. However, for our study, there are several challenges of using artificial intelligence that we need to consider. Our approach essentially involves analyzing a user's journal entries or their written text to identify their progression of mental health. However, it can be difficult to gather texts written by users with diagnosed mental illness and healthy users, especially among children, due to other ethical issues. Also, we know that chatbots and other artificial intelligence tools may infer gender or ethnicity and show less empathy towards certain groups, leading to bias. Another practical challenge of using such a method is that data collection via mobile apps will require large amounts of time and resources. Therefore, we use the use of large language models or LLMs as a possible solution to generate and replicate user behavior and journal entries in the application. Our approach essentially has 3 steps. First, data generation. We collect journal entries and daily activity logs from our users. Then we perform sentiment analysis by analyzing the user inputs to determine the emotional tone and mental state from their writing. Lastly, we focus on future mental health predictions by using machine learning models to forecast mental health outcomes. So here's a diagram of our data-driven framework. Today, I'll mostly focus on the sentiment analysis model, the mental health score, and the user activity model. As you can see, the user activity model is trained from the user interaction in the app. And the sentiment analysis model is trained on the user's journal entries. However, we can see that this framework can easily be expanded to include a chatbot in the application, for instance, where the journal entries are sent to the chatbot. So the chatbot has context and awareness of the user's daily life, so it's able to provide more personal responses and support. This framework can also easily be integrated into more complex models, such as a personality model, or even include voice recordings in the future, such as using a speech emotion recognition model or a text-to-speech model. So next, let's talk about the journal, the user and data, the user and journal data. So we explore the use of LLMs in generating experimental data. By doing this, we devised two custom GPTs using OpenAI's API to create users and journal entries. Our first GPT generates user profiles with random age, gender, race, and ethnicity, city location, socioeconomic status, parental involvement, hobbies, and personality. These instructions ensure the diversity of the users and variance in the journal entries generated. Our second GPT generates journal entries given the profile of each child. Then we task the agent to generate 5 journal entries before and after the study, randomly deciding if the mental health improves, so that we can later use machine learning models to identify what activities are causing those improvements or if they got worse. Now I'll give a brief overview of the sentiment analysis. This part consists of 3 steps. First, we need to pre-process the data by cleaning and preparing the data for analysis. Then we will train our model by building and training machine learning models on the processed data. Lastly, we will perform hyperparameter optimization by fine-tuning the models to enhance performance. I'll get to this section in more depth later in the experiment section. Now let's take a look at the user activity data. The user interaction data is generated using a rule-based algorithm. This algorithm will simulate the number of times a user logs a certain activity in the app within a 6-month period, or about 180 days. These activities are characterized by their impact and correlation on mental health based on existing psychology research as either negative, neutral, slightly positive, moderately positive, or highly positive. For example, some of these activities we included are the number of gratitude journals they've written in the past 6 months, the number of journal entries they've written, the number of times they logged the weather sunny, cloudy, rainy, snowy, or windy, and other hobbies such as exercise, movie and TV, gaming, music, etc. So to explain how this works, if we know that an activity such as exercise has a positive impact on mental health, the algorithm will generate higher numbers, indicating that the user logged this activity more in the past 6 months. Also, the advantage of using a random rule-based algorithm is that the randomness ensures the data will not be linear and have outliers, but still retain a slight trend. Next, let's talk about the user activity model. Our goal is to investigate the relationship between daily activities and mental health outcomes, specifically the impact of the activities on the mental health score. Here, I should note that the mental health score is a percentage from 0 to 100 based on the journal entries. So it is essentially the output from the sentiment analysis model. Our data set, which we see on the previous slide over here, consists of user data with each row representing an individual user and columns with mental health scores before and after the observed period and their activities. We use linear regression, random forest XGBoost, SVM, and neural networks, which we'll get into more detail later. So next, let's talk about the experiments we performed on the different machine learning models. For the sentiment analysis, we pre-processed the journal data using tokenization, stop word removal, and TF-IDF vectorization. For deep learning models, we use word embeddings such as word2vec. And lastly, we perform hyperparameter optimization with random search. So out of the 5 models over here, we see that BERT has the highest accuracy across all of our metrics, except for random forest, which has a better training accuracy. However, as we see, random forest has a much lower test accuracy, which is a potential sign of overfitting. Our BERT model is trained using CUDA for efficient computation on GPUs. BERT, one advantage of using BERT is that it has bidirectional transformers to understand the context of each word in the entire sentence. Out of these 5 models, BERT had the highest train accuracy of 86.7%. However, despite its high accuracy, in our application, we still chose to use LSTM in the very end because BERT had a tendency to produce extremely polar probabilities, such as over 99% or 0.01%. We then performed some experiments on the user activity model. This consisted of 3 steps. First, we did feature selection by calculating the Pearson correlation coefficients between each feature and the after mental health score. Those features with low correlations were removed as they did not provide much useful information on the impact on mental health scores. Then, for our model development, we used the least squares method to minimize the sum of squared residuals. We apply grid search CV and randomized search CV for hyperparameter optimization and perform k-fold cross-validation to evaluate performance. Our model was evaluated using MSE, MAE, and R-squared scores. Over here in this table, you can see the scores for our 5 different models: linear regression, random forest, XGBoost, SVM, and neural networks. So out of these 5 models, we see that neural networks has the lowest MSE and also the lowest R-squared score, showing that it had the highest accuracy. Now it's important to talk about the results of this machine learning model. So over here we have a diagram of a chart of the coefficients, meaning their importance and the different activities and features we have over here on 2 different models: linear regression, which is our most basic model, and random forest. So here we can see that the mental health score before had a big impact on the mental health score after. And this makes sense because users who tend to be have a more positive mental state will likely still have a positive mental state even after a period of time, while those with a worse mental health may experience fluctuations such as an increase or a decrease after a period of time. Then we see that music and exercise and practicing gratitude are positive influences on mental health. Whereas a high number of exams or adverse weather, such as rainy conditions and gaming, have a negative influence on the mental health score. We see that these results support our data generation because we had positive features have higher data generation due to their psychology impact on mental health. It's also important to note that the importance scores provided by both the logistic regression and random forest models are similar, allowing us to confidently conclude which features specifically have a greater impact on our target variable. Our models did not incorrectly classify features designated positive as negative or vice versa. The only instance when these models showed slight discrepancy is when classifying neutral features incorrectly, such as slightly positive or negative. Now let's discuss the limitations of our study. One of the most important drawbacks is that our data set lacks clinical validity. Our data set was taken from Kaggle, meaning it's publicly available, and it consists of 1.6 million tweets categorized as positive or negative. However, our experiment could be improved if we use clinical data that is classified using clinical terms, such as those specifically relating to mental health and whether the user has specific mental health conditions such as anxiety or depression and how extreme they are. Also, our accuracy cannot be verified beyond positive or negative. Because our data set was labeled using a binary classification and our output is a continuous probability from 0 to 100, we can only verify our accuracy as either greater than 50% as positive or less than 50% as negative. So our models may fail to capture the nuance or the extent of their mental health state. Lastly, the rule-based algorithm does not account for real-world user behavior. Because we know that in the real world, certain behaviors may have a correlation with each other, such as perhaps we see higher exercise may correlate with less sleep. But by randomly generating these data, we may fail to capture some of those real world patterns. Last, I'll conclude by saying that machine learning can be used in mobile applications to predict changes in mental health based on written journal entries and activities. Through our study, we see that LSTM and neural networks achieve the best results in predicting wellness outcomes. Our research has social impact because it reduces the burden on mental health professionals and helps individuals and families manage mental health. In the future, we should focus on validating these models with real-world data and integrating these tools safely and efficiently into existing healthcare systems for maximum benefit. Thank you.